Hi, I bet that music's got you all pumped up, so what better way to use all that excess adrenaline than to dive into a stats problem? This isn't really a podcast all about statistical calculations per se. It's a way of speeding up what you've probably had to do loads of in the past, and that is generate some tables of values in order to use your mean and standard deviation formula. The main thrust of this short podcast is to show you how to access these totals that you can see in blue at the bottom of the table here, and the individual mean and standard deviation calculations directly from your calculator. Now, I'm using a Casio, but it doesn't necessarily mean that I'm endorsing that as such. It's just the calculator that we have available. For the mean, you can see I've already previously done this. In an exam type question, you would just get the first two columns, the data values themselves and the frequency. And whilst this is discrete data, the principle still holds the same for continuous data. The only extra bit would be that you would find mid-interval values before proceeding. So for the mean, remember we want the sum of f of x over the sum of f. So let's just work out the answers now, and we can see that it's 130 over the 52. Doing that on the calculator would give 2.5. If we do the calculations first, then you can see when we access it on the calculator you get the same result. Now the standard deviation, the notation I'm going to use is sigma x, only so that that ties in with what your calculator will give you shortly. I do mention it later, but we're talking about populations here just to make things simpler. If you do the A-level Stats 2 module where we start talking about sampling, then you have to consider bias and unbiased estimators, but that's overcomplicating what we need to do at the minute. So we need the square root of sigma fx squared over sigma f minus the mean squared. Purists amongst you might say, well, why am I not using mu? Well, I'm not. So what do I want? I want the square root of 538 over 52 take away 2.5 squared. Doing that on the calculator gives me 2.02 2.024. So those are the calculated values, and these tables, these columns at the top, f of x and f of x, fx squared, and the sums of, that's how you would go about it if you weren't going to use the stats modes on your calculators. So let's break there and go straight to using the calculator. Right, I'm using this emulator on screen, which you can see is a Casio version, but a lot of the functions are very similar to most of the calculators you're likely to have to hand. So let's start by first of all making sure that when we put this in statistics mode, it's going to be able to accept frequencies. So we need to go to Shift Mode, and the option we want is not shown on the screen as it is, so we need to move down and choose option 3. Now what we want here is for the frequencies to be switched on. If you were doing work involving two variables, so linear regression or correlation for example, then you would probably want the frequency switched off. But we'll go right ahead and put 1. Now that's just set it up so that we can accept frequencies. It's still not in stats mode until we change the mode to mode 2 in this particular calculator. We want one variable mode because x is the variable here with associated frequencies. If you were doing linear regression or bivariate data, you'd choose option 2. So now we have the frequency table with values ready to put in. This is the long job, so I'm going to cut some of this out, but I'll just make a start and show you that when you put 0 in for the first data value, you have to hit enter so that it recognizes it. Notice however that it's put a frequency of 1. I think that's just so that it defaults to something. In this particular case we want to be able to change it, and equals every time enters it as you would when you're entering information on a spreadsheet. So we navigate around, putting the relevant values in. hitting equals each time. At any time we can go back and edit the data, as we can if we want to do a different question and just vary the numbers slightly. We can always get back to this table shortly. I'm going to cut it in a minute because this is tedious, you watching me put values in. So there we are, the data's entered, and you can see by just moving up, there's the whole table. Notice this left hand column here, 1, 2, 3, etc. just keeps a track of which row you're on. Other than that, it doesn't serve any purpose, and it increments even though you don't necessarily want to carry on. The next bit is the scary bit. This is where we need to clear the display by pressing AC. That doesn't delete the data, it simply clears the screen. Now this is where the stats functions come in. You see, we're in stats mode. We've had a stats setting to get the frequencies ready. This is where we access the functions by going to Shift button 1, and that brings up the stats options. Now option 1 just changes the type from what we chose originally, which was one variable. 2 brings the table back. 3 obviously allows you to edit things. 4 is what we want initially, because we want sum of f of x and sum of f. Well, notice here we haven't got sum of f of x, but we've got sum of x, which is the calculator's way of saying the same thing. So referring to the table on the right, this should be 130 if I choose option 2. Hit equals to access it. Yes, it is. Go back to that set of options. Option 1 should give us 538. We also need to know sum of f, and again the calculator seems to avoid using f for frequencies. In this case we go to Shift 1 and choose 5, and you can see here that we have got option 1 being n, which is 52. So the calculator calls it n, we're calling it sigma f. What the calculator will also do is work out the mean and the standard deviation for you. Let's show you how to get those. Shift 1, and we want option 5. Now choice 2 gives us x bar. We know it's 2.5 as you can see to the right. There we go. For standard deviation, we want x sigma n. It's a bit of a clumsy way of representing it, but it's option 3, and we can see that is 2.0238, etc. So to 3 decimal places it's the same as we've got here. Remember what I said earlier, choosing the other option for what looks like the standard deviation, option 4, that's more to deal with samples and populations. So rather than confusing the issue, at GCSE and things like S1 module, just ignore that option completely and we're all good. Okay, I hope you found that useful. Don't forget, each time you want to do some more statistical calculations, make sure you clear the memory. But I hope that speeds up what can be somewhat laborious and tedious calculations. Check back again soon. Thanks for listening. Bye.